in this right now. So if we come to our, this thing has been taking forever to load. Okay. I believe we all can see my screen at this point. Please, if you are not seeing my screen, just drop a message so that I'll be able to know. Someone is dropping. Okay, nice. Okay, so this is where we are. We're able to create our connections. We're able to create our base plates. Okay, so at this point now, all we need to do is to understand how to generate our detailed drawings, because at this point, we have done our analysis, we have done our design, we've created our connections. The next thing that is remaining is just for us to export our drawings or generate our drawings. And we can generate our drawings from here right away, okay? All we need to do is to come to, you can see here written drawings and reports. You can see here written drawings and reports. So under your drawings and reports, if you come to here, you can see perform numbering. This is the first step you should take. You click on perform numbering, and then you click on apply and start numbering. So it's going to do the numbering. But sorry, I made a very big mistake. Now it's not going to create numbering for us because I did not highlight the model. You are supposed to highlight it first. Then you come to drawings and reports. Then you click on this drop down here. Click on perform numbering. Click on apply and start numbering. Okay. Okay, nice. So that has been created. You come to create drawings. So if I click on this drop down here, I'll click on assembly drawings. You can see the model is still highlighted. I'll click on assembly drawings. So once you do that, here it's telling you to create, open, or manage drawings. Press F9 or double click on Drawings Manager in the Explorer. Now, this is the Drawing Manager. If I double click on it, it's going to open. Or if I press on F6, I think that was F6, yes, it's going to as well create that drawings for me. Okay, now let me bring this down here. Now, if I bring this down here, here is showing me, you can see all of these are unchecked. And then the landscape here based on our dimension is showing AO, that's the size of paper, okay? Type not assigned. It's telling us that all of these are actually closed. So we have to open each of these in order for us to view the detailed drawing that was generated. Okay, so you can see the drawn marks. Now, in order for me to open on any of these drawings, it's just for me to select, and then I can come here that is written open drawings. If I click it, it's going to open it for me. But let's say I want to open all of these that I highlighted just now, and then I click on open drawings. Okay. The next thing here is to close. I can come here and click on close. Once I click on close, you can see the detailing that has been generated for me. Okay. You can see that anchor bolt. Now, this is not the entire detailing. Okay, this is just showing us our base plate so far. You can see it actually gives it a name based on like a serial code or something. So this is 001, this is 002, 003. You can rename them while you are trying to export. Okay. You can view based on your views, your plan view, your 3D view, and all of that. So this detailed drawing as it is, you can as well export your detailing that has been generated by this software to your AutoCAD. Okay, you can export to your AutoCAD. I prefer to print my drawing or arrange my drawing in AutoCAD. It's much more easier and it comes out much more presentable than in it here. Because you know AutoCAD is more manual, you just tend to have it's very flexible. It's very flexible software. It has tools that can help you manipulate whatever you want to do much more easier, faster, most especially when you have existing. Okay, so you can see for yourself, these are detailing for this particular design that we did for our overhead tank. Okay, let's say for example, I want to generate or I want to export this detailing that was generated by this software for me. Now, this is 002, okay? So all the detailing has been generated. You can see this is your stanchion, your column, okay? Everything has been generated for you. So whichever one I want to print, for example, or I want to export to my AutoCAD, all I need to do now is to come here and I will click on export DXF. I click on that export DXF. At this point, I will click on this that is showing 3 dots. If I click on that, now, before then, see the scale here is telling me that this scale is 1. Okay, it's at scale 1. Now, I can change the scale to suit probably the setting of my AutoCAD. So what this means is that this is going to be 1:100. Okay, so this is actually going to be 1:100. Okay, so now if I click on these 3 dots that is here, it brings me here. Now at this point, I can specify my directory, specify where I want this drawing to be saved in my system. I can probably create a special folder and that whatever detailed drawing I'm generating, it will automatically be saving inside that particular folder. So let's say I want this drawing to be saved inside this folder that I called latest design. All I need to do is to change probably, or if I want to maintain the name, I can maintain it. I can name this practice. So if I open this, so I'll click on export. Now it has been exported. latest practice. Yeah. Okay, so if I come to my document, come to latest design, you can see the file here, practice. Sorry, I'm using AutoCAD 2023. Hope you know that the 2023 version is no longer carrying the same logo like the other versions from 2022 downward. It has been changed for all Autodesk softwares, both Revit, both Civil 3D, both robots, both whatever Autodesk software that you know, it has been changed to this. So it's no longer looking like the normal way it's looking before. So you can see even all my AutoCAD drawings. You can see how they are looking. So if I want to open this now, I will just double click on it and it will open. Z, enter, E, enter. Right. So you can see my detailed drawing here. So the next thing you need to do is just arrange it the way you want to arrange it. You can arrange it to your taste. Well, you know, you have to put in mind that this column is just a repetition. Whatever column you have here is the same thing as what you have here. It's the same thing as what you have here. Same thing as what you have here. So, you know, Protastructure normally will just generate all the detailing for you. So you just, instead of you to start printing the same type of column over and over again, you just pick one of it in your arrangement and you print. Even the brace, okay, you just pick one. You don't have to generate plenty sheets, which is, this is you saving costs for yourself. Even the design report as well. You don't have to keep repeating the same when you have one particular type of column, because as it is like, this is one type of column entirely for the 4 different supports. So you are definitely going to be having just one type or two. So there's no reason for you to keep repeating the same reports over and over and over for your brace, for your column, because the software tends to give each column a different name. Okay. So that is that. It's as simple as that. The other part of the drawing that I did not generate, let me click on Drawings Manager. If I double click, it brings me back here again. I can as well highlight them too and open them. If I click on open, you can open everything as a matter of fact. Okay, so before I go there now, let me show you something. Here, you can see, if I switch on, now, why I'm not seeing anything under A3 is because the paper size there is showing AO, okay? That's why every drawing under AO is what is showing. So all you need to do, you can do all that from your settings, okay? You can see down here, it has settings, it has export. Okay, you can see it has exports. You can even create like a custom paper settings. You can create different type of paper. If you know that your paper normally for A3, the standard size of your A3 paper, standard size of your A4 paper, you know, your AO, when you fold AO and you fold them into 2, it becomes your A1. If you fold A1 into 2, it becomes your A2. If you fold A2 into 2, it becomes your A3. Similarly, like that, continuously until the last size of paper. So that's just exactly how it is. So if you know the size of your A3 paper, which is the width of A3, I think it should be 420 by 27, I mean 97. I cannot remember specifically. Let me check. Let me try to print something. Oh, sorry. Aha, you can see A3 is 420 by 297. Okay, I'm correct. So by 297, you can just give it a name. So, and you click on create, and it has created that paper for you. So you can generate it for all types of papers and have all different sizes of papers here. If you want to be better, by standard, we use A3 to print our drawings, except when you are printing road designs. But if it's structural designs, it's A3 paper we use. Except if you are printing for road drawings. So if it's not road, if it is structure, anything that has to do with structure, mechanical and electrical service drawings for buildings, architectural working drawings, both whether 2D drawing or 3D drawing, they are all in A3 size of paper. Okay, so that is that. Here, create drawing, create copy, delete a drawing. Any drawing I want to delete, I can just, once I click on this delete, then it goes. It's asking me, do you want to delete the selected drawing? I can decide to say yes. Maybe I don't want it. I just click on yes, and that drawing is deleted. So let's close this and go back to view story F, story 1, story 2, story 3, story 4, story 5. So you are going to be seeing the plan view of each of this story. Just for example, maybe you want to print that part of it. You remember our story 1 contains where we have the reinforced concrete column, right? Then our story 2, from there upward, it was still all through. And then story 5, that's where we have our pull line. So you are going to see all that by click on close now. If you come to, I don't know what story is this. This is 5, nice. You can see at 5 now, you can see this is the pull line. This is showing you, these are the pull lines, okay? From the plan view, that's if you are viewing it from the top. If you come to story 1, you can see it's showing us our base, okay? You can see our base, where those are those knots that we actually inserted. And you know, we did not maintain the same type of base plates in the drawing. We're just playing around the whole thing. That's why this one and this one and this one, they are not looking similar, because we use different types of base plate, if you can remember. So if I come to story 2, oh, sorry, I clicked on the wrong thing. Story 2, you can see from this point now, this is where we are just having only the steel member and then the horizontal brace that was there. That's that. As simple as that. So everything is easy from the beginning to this point. We're able to run a model. We're able to import steel cross-section. Like I said, all you need to do is just to sketch out a steel cross-section anyhow, irrespective of how the shape of that steel cross-section is. You can just sketch it from your AutoCAD and then just import it. The Protastructure will, for as long as your drawing is actually the way it should be, Protastructure will, all you need to do is just to assign the type of chord that are there. If it is a diagonal chord, you assign it there. So just tell Protastructure, this is a diagonal chord, this is a top chord, this is a bottom chord. Once you tell the Protastructure, this is what you are assigning as each of those chords, that is all. It recognizes them. You run your model, model, irrespective of how the shape of that model is coming. It's very easy. You can see how the tools are. They are very easy. Funny enough, I think steel design, I don't know, if you ask for my opinion, I think it's not as very complex as reinforced concrete. I'm not talking about manual design now. I'm talking about when we are coming to modeling. I think we play around with more of reinforced concrete buildings than when it comes to steel. Most especially steel, you see more of warehouse. They are always very straightforward. They're always very straightforward, except where you are having like a what they call it, like a garage. That's where sometimes you see some kind of aesthetics there. Maybe like a stand. That's where you see some kind of aesthetics there. Where they are always not very complex. They are always very, very straightforward when it comes to modeling steel. So that is that. At this point, you can bring in your question. Probably, I know most of the challenge most of us had has been the challenge of the software. I think that's the major complaint I've been getting from day one to till today, honestly. And one thing about these softwares is that a lot of things can affect the installation of softwares. A lot of things can affect the installation of softwares, most especially when your system is Windows 10. Try as much as possible. Windows 7, Windows 8 are not very, very complex as the way, if you ask for my opinion, when it comes to installation, like the way Windows 10 is. Windows 7 is much more easier, very straightforward when it comes to installation. Only that most of the softwares now, the latest updates does not really support Windows 7 anymore. Most of the softwares, the latest updates now, maybe if you are looking for updates up to 20 from 2022 to 2023 now, some few softwares that I've encountered, you cannot install them in Windows 7. So the Windows 10, once it's updated up to date, so always try to update your Windows in order for you to enjoy whatever you want to do. I'm going to show you how to update your window for the sake of those who probably have never done it before. If you come under your search, for those who are using Windows 10 most especially, all you need to do, okay, someone is raising his hands. Okay, yes, sir, I'm listening. You are not hearing me?
All right. Yes, I can hear you. Good evening, engineer.
Evening, sir.
Thank you so much for the great job.
Thank you.
From day one to today. All right. Please, this is my question. Reinforced concrete design.
Yes, sir.
I think almost every one of us, we are familiar with the printout, the drawing, the number of drawing we need to print out when it comes to reinforced concrete design.
Okay.
Beam, column,
okay.
All those elevation and everything. But for this steel design, can you please tell us what and what is required to print out?
Okay, I'm going to tell you. When it comes to steel design, what you need to print is all the structural members that you have designed. For example, for this overhead tank that we just designed, okay, we designed, it has a column, 1. It has a reinforced concrete column that is carrying the steel, which is 2. And then that stanchion that is on top of that reinforced concrete is connected by a base plate. Okay, that is 3. Then it has an anchor bolt. Now, everything that has to do with that steel, you have to generate them. So there is an anchor bolt, there is a base plate, there is a reinforced concrete column. Don't forget, it even has a foundation down, which you may probably want to choose a foundation, whether you are using a strip, whether you are using an isolated pad, whether you are using, it could even be a pile, whatever kind of foundation, you have to generate that too. That's for the reinforced concrete. Then when it comes to the steel member, that's the stanchion, the base plate, and whatever they are using, whether it's a nut, that nut that is there, even that base plate, that stanchion that is on top of that base plate, sometimes you even have a weld in order for you not to be having a clash. Then when it comes to the bracing too, you have brace on it that is bracing that particular column. You generate that. It has probably a horizontal brace, or it could be a steel beam. You generate it. Okay. When it comes to the pole line, around the roof level there, at the roof level, you have probably the beam, which is there as the primary beam. Then you have probably the pole line, which is acting as the secondary beam there, that is there. And on your pole line, sometimes there are cases where you even have a pole line and you even have a brace, which I demonstrated in one of that model we did. If you were not around, you must have watched the video where we had a pole line and we also braced it at the top there at the roof level. So you have a brace. So everything that has to do with the design, you are generating it. You are generating all the detailings. Then aside that, each connection that connects any structural member, you are generating it. You have a column that is breaking. That column, whatever you are connecting the column at the story 1 with the story 2, you are generating it. If you have, it is a steel column. You have a column as story 3, you have another one as story 2. You are connecting those two columns together, which is a steel column. You are using a connection to connect it, which is a splice. So if you are using that splice, you are generating that connection as well. So that is why our detailing here, everything that we have generated from the beginning to the end was generated here in our detailing. You can see here we have an anchor bolt. We have an angle bolt. You can see it's generated. It has to be printed too, because there is a report for everything that you have modeled, analyzed, and also designed. So I don't know if I have answered your question. If you want to see samples of steel, I think still some samples of steel samples. These are some samples of steel, you know, but this is a warehouse. You can see this one here. We have, you know, sometimes some of these softwares may not generate your detailing 100% exactly how you want it in your head. You understand? So some of these things, you have to add some few informations to them, to some of the detailing even that is going to give you before you print. So if you have this from the plan view, you know, this is a stanchion here you are having. Then this is just the foundation layout. Then at that place where you have the cross section of your base, here you are having a base plate. You are having that that bolt here. You know, the thickness of that base plate, the width of that base plate, everything has been generated from your detailed drawing. Then you are showing the base plate itself. You are showing every information that has to do with it. And then at the foundation level as well. But you know, the foundation, which is reinforced concrete. Then at the roof level, you know, you generated a pole line. You had a pole line there. Probably you even had a brace there, you know, at that level. is showing at the roof plan. Then you come to the main cross-section of that particular steel. When you are doing design, the architect has to give you the cross. That's why the most important thing to you when it comes to steel, most especially, is the cross-section. In short, that's the most important information that you need from the architect, is the cross-section. Okay, show us the weld details of this design. Was this well designed? Was this weld? Okay, did we even include weld in? Okay, I'm not sure if I included weld, but let me explain this. But to include weld is the same principle as whatever that we have been doing from the beginning. When it comes to connection, it's very, very easy to apply your weld. I'm going to show you that. Then, like I was saying, the most important information you need is the cross-section. The cross-section of your steel is the most important thing to you, which the architect is supposed to make provision for. Because that is what you are actually going to be using for your model. So in whatever shape that cross-section is coming, for example, if it's coming in this shape, you have to maintain that particular shape. So your responsibility is to make that particular steel to actually stand, except in a way that you have done everything possible that has to do with the design and it's not working, then you have to call the attention of the architect. Both of you agree with each other. You tell him the reason why there is need for you to change probably the cross-section of that steel and all of that. There are cases like that too. Because, some of them may want to just generate just model a design based on, some of them are just concerned about the aesthetical part of the design. They are not really concerned about the stability of the building and all of that. So you as the engineer, it is your responsibility to make that particular structure stand. So once you are done with all of that, then your connections, your polyline, your entire connections are the next thing you generate. So it's actually as simple as that. Even the detailing you generate from manually with pencil and paper, that's not